All right, Bismillahirrahmanirrahim. Students, let's start a problem related to frames analysis. Specifically speaking, this is a frame problem. Okay, so in this problem, basically, if you see, uh, it is saying that the compound beam is supported by a rocker at B and is fixed to the wall at A. Okay, so what is it saying? There is a rocker at B and fixed to the wall at A. It is hinged pinned together at C. Okay, here it is being hinged pinned together at C. Determine the components of reactions at the supports, which means he is interested in the reactions of the fixed support and he's also interested in reactions of the rocker. Okay, now you know that the fixed support will give us three reactions over here and the rocker will give us one reaction. So what does this means? That all together, if you look at it, there will be basically four unknowns. If you look at it, there will be four unknowns. Okay, so if you look at it here, there will be four unknowns, and we can assume that one of the unknowns will be this will be an unknown. We can assume this is an unknown, and we will assume since it is a fixed support, it will also have a moment. Okay, so we will say this as MA, this will be AY, this will be AX. Okay, and you will say that there will also be a moment here. Look at it, there will also be a moment here. Okay, and you can call this as, there will be also a reaction here, and you can call it as this reaction as by. This reaction will be by. So if you look at it on this frame, which is a compound beam, there are basically can say there are how many unknowns here? 1, 2, 3 and 1. So you have unknowns, 4 unknowns. You have 4 unknowns and equation of equilibrium are 3. So this is a perfect example of a statically, it is a statically indeterminate problem. It is a statically indeterminate problem. Okay, so for this problem, in order to solve this problem, we have to break this beam, the compound beam, into respective components at A and C and C and B. Okay, and very important point that this is basically, if you look at it, this point here, this is going to be your pin. This is going to be your pin. This is your pin. Okay, and pin, at the point, at the pin, we can basically break this compound beam into two respective components. It will be from A to C and C to B. Okay, so if you look at it, if we break it at the pin, and at the pin will basically, remember, the pin will always give you two reactions. It will give you two reactions, and the fixed support will give you three reactions. It will give you three reactions. Pin will give you two reactions. Okay, so it will give you two reactions, pin, and the fixed support will give you three reactions. So we will start from CB. As if we start from CB, we will be basically, it will be easy for us to basically apply the equations of equilibrium, because if you look at it at CB, you will have we will assume the direction. This will be Cx and this will be Cy. Cx, and we will assume this, and also we will also assume that this is the direction of the your rocker. This is the direction of your rocker. And what is this direction? Basically this is by. So just concentrate, if you just concentrate on CB, okay, so you can write it here as this is your member. You are considering this as member CB. Member CB. This is your member CB that you are considering. So now we can solve this. If we solve this, we will get if we apply sigma fx over here, okay, if we apply sigma fx over here, we will have two components, okay, and if you look at it, one component will be Cx and the other component will be basically this component and the other will be this component, okay, this component. This will be your it will be 200. This horizontal component will be 200 cos 60 and this will be 200 sin 60. Remember this thing, it will be 200 cos 60, 200 sin 60. So when we apply sigma fx equal to 0, if we apply sigma fx equal to 0, here if we apply sigma fx equal to 0, we will get Cx plus 200 cos of 60, 200 cos of 60 is equal to 0, and from here we get our Cx is equals to how much? It comes out to be minus 100 pounds. Minus 100 pounds. This component, see, this is positive acting. If you want, you can, for your easiness, we can easily edit for your, you can say this is your positive x and this is your positive y. So Cx is minus 100 pounds, okay. Now if we are interested in, basically we have calculated, if you look at it here, we have calculated the value of Cx. Now we need two unknowns, Cy and By, okay. So now for our easiness, in order to calculate By, we will take moment at C, okay. So if we take moments at C, summation of, we'll say summation of moments at C is equal to 0. This is C. At C equals to 0, we will say we are taking anti-clockwise moment as positive. So if we are taking anti-clockwise moment of here as positive, so all these here basically the Cx Cy will become 0, and this vertical force 200 sine 60 will be the force times the momentum till point C is 8, and this By will have a momentum, it's a force, it will have a momentum of 12 feet if you look at it, and the other is this 4000 pound feet at B. So now we can very easily write here as, let's see, and again this is going to be minus 200 sine of 60, okay, minus 200 sine of 60 into 8, okay, this is minus 200 sine 60 into 8, okay, and you know that this 8 is the momentum of this force. Then it is going to be plus By into 12, this is By into 12, the momentum. This is positive because it is taking the beam segment to anti-clockwise, and if you look at it, it is fixed at C. This 200 sine 60 is negative because it is taking us in the clockwise direction, and here if you look at it, this 4000 pound feet is again is a force which is a movement in the clockwise direction, so minus 4000 is equal to 0, okay. So this is done. Now what we do, basically we know that here this is minus 200 sine 60 into 8 plus By into 12 minus 4000, okay. The Cx and Cy are basically 0. This is By into 12, this is 200 pounds force into, so times sine 60 into 8. So from here if you look at it, you can basically very easily calculate, all the values are numerical in this equation, and you can easily calculate your By. By can be calculated as By is equal to 448.80 pounds, okay. This is your By. So now once this has been done, we can basically say that By is calculated, Cx is calculated. Now you can basically apply sigma. If you apply sigma Fy, sigma Fx, two equations are used while calculating the segment CB, member CB. Now you can say sigma Fy is equal to 0, okay. So just for direction, this is going to be our respective direction, this is going to be our respective sigma Fy equal to 0. So what we can say over here is that when we apply sigma Fy equal to 0, what are the forces that we are going to take into account? Cy, positive Cy plus By, and minus 200 sine 60, okay, because there is no moment, only forces are here. So it will be Cy plus By towards the positive y, and what will happen here for the other force, minus 200 sine 60 is equal to 0. So from here what do you get? You get your Cy equals to, and again if you want you can just make it more easy, because your unknown is basically Cy here, and you have already calculated your Dy. Your Dy was, this was your Dy, this was your Dy. So Cy plus what was By going out to be 448.80 minus 200 sine of 60 is equal to 0. Okay, so what does this tell us? That from here we can say cy comes out to be equal to minus 275.60 pounds. Okay, so now we have calculated our cx. This is our cx, and we have also calculated our cy. Cx, cy and by are calculated, and our member cb was there. Okay, so if you look at it again, now we will basically be going to where we're going to go to member, this member here. This is our respective member if you look at it. When we want to calculate the force for the member AC, we already know that this was our C, this is C. Okay, this is point C. Now just remember that when we're doing CB, these were the reactions of CX and CY. Now when we do, this is your member. Now we are doing member analysis for member. Okay, this is member AC. This is member AC. This is member AC. Now for this, we know A will have basically three unknowns, because it is a fixed support. Since it is a fixed support, so we will draw three unknowns. This is EX, this is your EY. Now C will have, very important, these are the direction sense for CX we assumed. Now this will be your here we will assume that this is our CX, and we will assume this is our CY. CY, CX. It is totally opposite. Very important point. It is totally opposite at the pin. Okay. This point has to be remembered for the calculation when we are going to do these calculations here. So again apply. Can we solve it now? If you see, we know CX, CY, and what about we don't know AX, AY, MA, so we can easily calculate. We can apply in the start. We can say we can calculate AX, and if we calculate AX, we have to apply sigma fx is equals to 0. So just apply it. We will have AX minus CX and minus, now the force is 500, and it is going to be 5 by 13, since it is the horizontal projection of 500 pound force, is equal to 0. So you know You don't know Ax, but you know Ax minus what was Cx that we calculated before. The value of Cx was minus 100, so we can write it as minus 100 minus 500, 5 by 30 is equal to 0. So what is going to be your Ax now? What is going to be your Ax? It's going to be 92.3 pounds. Now we need to calculate sigma Fy. Okay, so instead of before calculating sigma Fy, if we calculate sigma Fy, you will say we have basically Ay, Cy, so we have two unknowns. So it is better we calculate here. In order to calculate, we have an Ay is the unknown and Cy is basically the known value. So if we apply sigma Fy is equal to 0 here, and you know that this is going to be your positive y-axis. Okay, this is very important. Okay, so now what is going to be sigma Fy? So what are the forces in y? Ay is going to be a force. This is our assumed direction of Ay, Ax. Okay, so we can say as here again we have assumed direction Ax here, and we have you can say this is here, but this was our assumed direction. We can assume because we have assumed it. This is our Ay. This is our Ay. Okay, this is our Ay. So we can say this Ay is going to be a positive value. Then Cy is going to be a negative value, minus Cy. Ay minus Cy minus, what about this 500 force vertical component? It will be minus 500 into 12 upon 30 is equal to 0. So you do not know Ay, but if you say like you know what is going to be your Cy minus, so for Cy minus 275.60 minus, if you multiply 500 with 12 by 13, you will get minus 461.54 is equal to 0. So this is being done. Once this is done, you can easily calculate your Ay, and all the values or numerical values have been calculated. So there is only one unknown. Okay, you can say there is only one unknown, and your Ay comes out to be how much? Ay comes out to be equals to 185.94 pounds. 94 pounds. Okay. So this is being done. We have calculated your Ax, we have calculated your Ay. There is one unknown still left, which is the summation of moments at A. Okay, so we have to calculate this unknown. Okay, so again, if you look at it, we have assumed just for easiness, we are going to take it here for calculation of the moments at A. Okay, so remember, this was the sense for this was our Ax, remember, and this was our Ay, this was our Ay, this was our moment, this was our moment MA, and remember this was our Cx, this, and this sense for Cy, this was our sense, and this was our point C. This was our point C. Okay, well, you know it already, but just for making calculations easy, this was Cx, Cy, Ax, Ay. Okay, Ax, Ay, Ma, Cx, Cy. Okay, now calculate, if we calculate the moments at A point, okay, we can calculate the, it will be easy for us to calculate the moments at A, because it will directly give us Ma. Okay, so we write it here as summation of all the moments at A is equal to 0. Again we will assume that anti-clockwise mode will be positive. So if that is the case for it, for this member AC, we will write it here, because remember at A the forces will be 0 but the moment will always be active. Okay, because you know, a couple moment is basically a free vector. Okay, so this moment at A will always be 0. So this will always be active. Ax, Ay will be 0, and you can calculate Ma, because a moment can never be 0 at a specific point. Okay, so you can say that this, or if you want to make an equation, it will be Ma, since it is basically this Ma is anti-clockwise, then the other component will be basically minus 500 12 by 13 minus 500, and again this Cy, if you look at it, this Cy is going to be again a clockwise movement, minus Cy into 8, and one more thing, here it will be, the moment arm will be multiplied by 4, minus 500 12 by 13, this force into 4 feet the moment arm. And what about this one? This is minus Cy into 8. Okay, and is equal to 0. Okay, so now if you look, the you know that you don't know value of Ma. Okay, but you know basically the value, you can calculate the value of this as minus 184 minus 18 46 minus 1846.15, and this is going to be minus, and Cy was minus 275.6 multiplied by 8. Okay, so it was multiplied by into 8 is equal to 0. So now all the in this equation, you know all the numerical values. There is only minus Ma, minus 1846.15, minus minus plus, it will be 275.6 into 8. So from here you can calculate your Ma will come out to be equal to, if you solve this equation, simple equation, your Ma will come out to be equals to minus 358.65. Okay, 358.65 pounds. So remember, what does this mean? This means that the direction of the movement here that we assumed, the direction of the movement that we assumed here is wrong. Okay, this minus is same. So that is possible. We can assume a wrong direction. The actual direction will be in the clockwise direction. Okay, so here basically this is how you basically perform your frame analysis. This is how you perform your, when you okay. So I hope you have understood it, and in the next we will do some machine problems as well. We'll do a machine analysis. We'll take a machine problem and try to solve it. Okay. So thank you very much, students. Inshallah, we'll meet in the next meeting.